Hello, exceptional Mrs. Whitney's math students. So today we're going to do 2.2 lesson adding rational numbers. We're probably going to take a step in the Wayback Machine for some of this and kind of revert back to when we first learned how to add and subtract fractions. So we're going to start with example 1, which is adding negative 3/8 plus 5/6. This really isn't that much different than adding fractions to begin with, except we're going to do your favorite, which is finding a common denominator. And I know that that can be a little bit of a struggle. And I'm trying to get my tablet to work. There we go. Okay, so we're going to take, I'm still waiting for my tablet to work. Okay, so back to my tablet. So negative 3/8 plus 5/6. First thing you're going to notice is that we do not have a common denominator, so we can't add them because we can't add 8/3 to 5/6. That's like adding apples and oranges. So we need to find a common denominator between the 3 and the 6. And it turns out the lowest common denominator is actually 6. So in order to change the 3 to a 6, we're going to multiply it by 2, and we're going to multiply the 8 by 2. Negative sign comes along for a ride. So we get negative 16, because 2 times 8 is 16. 2 times 3 is 6. So we get negative 16/6, and we're going to add it to 5/6. Here's where we're going to go and trip in the Wayback Machine. Remember that we don't add the sixths. We're just adding the number of sixths that we have. So we're going to put this over 6. Then we're going to take negative 16 and we're going to add it to the 5. This kind of clears up a little bit of the confusion of what we're adding and what's positive and negative and how do we do this. Remember, if I'm writing it down on here, you're writing it down in your notes or I'm going to send you back. So we say this is equal to, well, we know it's sixths. So negative 16 plus 5. Are the signs the same or different? Well, since they're different, we're going to subtract. So 16 subtract 5, I have 11. Is it positive or negative? It is negative because we have more negatives than positives. So we end up with negative 11/6. Well, we can simplify that. The number of times that 6 goes into 11 is once. Don't forget the negative. Remember, leave no sign behind. And if we subtract 11 subtract 6, we end up with 5. So it's negative 1 and 5/6. All right, adding rational numbers with decimals. Slightly easier because we don't have to find common denominators. Are the signs the same or different? The same rules apply whether they're rational numbers or they're integers. Since they're different signs, so different signs, so we're going to subtract. So we take the larger absolute value, which is 7 and 62/100ths, and we subtract 4 and 5/100ths. There's a decimal point in there somewhere. Okay. Well, I can't take 5 away from 2, so I'm going to have to borrow. 12 subtract 5 is 5, 6, 7, 8, 9, 10, 11, 12, 7. 5 subtract 0 is 5. Decimal point stays there. We end up with 3. And it's positives because we have more positives than negative. So positives, remember B/C means because, more positives than negatives. So this is the same as you learned with integers. The only difference is it's slightly more difficult because we have rational numbers. Evaluating expressions. So this is actually one of my favorite things to do because this goes back to algebra. So if I have 2x, which by the way means 2 times x, plus y, and we know that x is equal to 1/4 and y is equal to negative 3/2. So wherever I see an x, I put in 1/4. So 2, remember this is times 1/4 plus y. We know y is negative 3/2. halves. Well, order of operations says I have to multiply first. So, and remember, when you're multiplying, you just multiply across. So 2 times 1 is 2. 1 times 4 is 4. Again, plus the negative 3 halves. Now, since I'm going to add at this step, I know that I have to find a common denominator. And the least common denominator is 4, unless I simplify. I can simplify this to 1/2, so I get 1/2 plus a negative 3 halves. And remember, I told you to rewrite it so that the common denominator is 2. We take the 1 and we add the negative 3. Makes this slightly easier. So 1 plus a negative 3, signs are different, so I subtract. 3 subtract 1 is 2. I have more negatives than positives, so I'm negative. And it's negative 2 over 2, or just negative 1. I know, it's a lot of work, but you have to copy down each of the steps so that you know what you did. In fact, let's go back here and add, and let's see here. So this step we're going to substitute. Here we, then we multiplied. And then the next step down here, we added. And then there we just simplified. So real life application. The table shows the annual profits in billions of dollars of a financial company from 2008 to 2012. Positive numbers represent gains and negative numbers represent losses. Which statement describes the profit over the 5-year period? So we're going to take these numbers and we're going to add them all up to figure out what the actual, what was the profit. So negative 1 7/10 plus negative 4 75/100 plus 1 7/10 plus 85/100 plus 3 6/10. Well, I know that negative 1/7 or negative 1 7/10 plus 1 7/10, those are opposites. So I know if I add this to this, it equals 0, right? Because they're opposites. So 1 7/10 plus negative 1 7/10 gives me 0. So then I'm left with that number, this number, and this number. I'm going to add my positives together. So I'm going to say 3 6/10 plus 85/100. Remember to line up your decimal points. So I have 5. 6 and 8 is 14. Carry the 1, so I get 4 45/100 plus the negative 75/100. So I added these together. So now I have negative 4 75/100 plus the 4 75. No, 45/100. Oops, sorry guys. Let me erase that. Apparently I have to wait a little while to erase one. Okay, so plus 4 45/100. I'm going to take the larger absolute value, and I say negative 4 75/100. Subtract 4 45/100, and I end up with 3/10. Now you have to be really careful here because this is 3/10 of a billion. So we know that it's, so we also have to say, is it positive or negative? We know we have more negatives than positives, so this is negative. So I know it can't be gains. And it would be tempting to choose this because it's 3/10 of a billion, but it's a gain. So now we have a loss of 3 million and a loss of 100 million. Well, this is in billions, and so we're looking at either millions or millions. Well, in order to make it into millions, I'm going to move the decimal point over, and I end up with a loss of 3 million. Kind of complicated, a lot going on in that question. So, thanks for watching.